All right, seventh grade. Now let's move on to page 55. Let's move on to page 55, and we will see that we are approaching example 2, divide integers with the same sign. And the first example in example 2 tells us to simplify negative 27 divided by negative 3. Now, first off, we're going to pause here, and I want someone to let me know what the sign is going to be. If we're dividing a negative by a negative, what will the sign be? Great, yes, it's going to be positive because a negative divided by a negative is positive. And if you already know that 27 divided by 3 is 9, then you will know that negative 27 divided by negative 3 is also 9. However, if you did not know that 27 divided by 3 is 9, what you could do is reverse negative 27 divided by negative 3 into negative 3 times something is negative 27, by which you would get 9. Negative 3 times 9 is negative 27. Notice how a negative times a positive gives us a negative. This step is known as writing division as a product with a missing factor. Writing a division equation as a multiplication equation with a missing factor, with a missing number. When dividing integers with the same sign, the quotient will be positive. Another way you can solve this is by writing the division expression as a fraction. Excuse me. Now, this other way to do integer division, and we see this labeled as another way on the page 55. It seems like what they're doing here is taking the division and expressing it as a fraction, which is completely fine. And then they extrapolate or pull out the negative 1 from both the 27 and the 3. And then they separate negative 1 over negative 1 from positive 27 over positive 3. Negative 1 divided by negative 1 is 1, and 27 divided by 3 is 9, and so they get the answer of 9. Now, I'm going to give us some time to go ahead and try the triad exercises. So I'll pause the video here. Go ahead and try triad A, B, and C in your groups on page 55. I'll pause here. All right, now let's go over these. It looks like A says negative 40 divided by negative 5, and we know that since it's a negative divided by a negative, our answer is going to be positive, and 40 divided by 5 is 8. Positive 8 is correct there. Now we have for letter B a positive divided by a negative. Since one of them is negative, the answer will be negative, and 40 divided by 5 is 8, so here we have negative 8. And then letter C, we have 0 divided by negative 40. Well, 0 divided by anything will always be a 0, so that's the answer for letter C. Let's move on to example 3. It says write equivalent quotients of integers. Question says, are the following quotients equivalent? Justify your answer. So they have one quotient here, another quotient here, and a third quotient here. Remember, quotient is just an answer to a division problem. For example, if 10 divided by 5 equals 2, then 2 would be the quotient. Now, what's interesting here is they all have 18 in the numerator and 4 in the denominator, which means the absolute values of the quotients will all be the same. They'll all give the same number. It's just now a matter of whether they will all be negative or will they all be positive. In the first example, we have one negative sign, making the whole thing negative. In the second example, we also have one negative sign, making the whole thing negative. And in the third number, the third fraction, we have one negative that makes the whole thing negative. So whether the negative is in the denominator, as it is here, and the numerator, as is here, or is applied outside of the fraction itself, we will get the same answer for all three, negative 4.5, negative 4.5, and negative 4.5. It goes a little bit into a further detail. Here we do, remember, parentheses means do what's inside there first. Parentheses in math means do what's inside first. So we have 18 divided by 4. We do that first, then we make it negative. Here we have negative 18 divided by 4, which is automatically going to be negative, and 18 divided by negative 4, which is automatically going to be negative because one of them is negative. And here we have a generalization statement here. The value of negative, in parentheses, P over Q, is equivalent to negative P over Q and P over negative Q. What this means, class, is that it doesn't matter where the negative sign is. As long as there is only one negative sign between two numbers, the answer will be negative when it comes to division and multiplication for that matter. Let's move on to the triad at the bottom of this page. It says, which of the following are equivalent to negative 5? Aha. Well, we know it can't be this one because that's positive divided by positive, which is going to give us a positive 5, which is not negative 5. How about the second one? We know the inside is going to give us 5, but this minus sign here is going to make it negative 5. So this one seems like it'll work. How about this one? Same idea. Negative 55 divided by 11 is negative 5. Here's interesting because we have a negative divided by negative, which we know is positive. So even though it's 5, it's not negative 5. We can't count that one. And then this one here, 55 divided by negative 11. That works. That works. Negative 5. Positive divided by negative is negative. This one is probably the most challenging one we've seen so far. The inside. This inside is going to be positive 5 because a negative divided by a negative is a positive. However, this outside negative is what's going to make it negative. So the last one is equivalent to negative 5. Are there any questions, class?